Have you ever wondered what the universe is really made of? Our understanding of reality as it stands today tells us that the world around us, the stars above us, and even we ourselves are composed of atoms. These atoms, in turn, are made of smaller particles, protons, neutrons, and electrons. This has been the accepted truth for the better part of a century. Yet, in the grand theater of the cosmos, there may be an act even more fundamental than atoms and particles. Enter string theory, a mind-bending proposition that suggests the universe isn't made of particles but of tiny vibrating strings of energy. This theory dares to redefine our understanding of matter, of space, and of reality itself. The stage is set. Our journey into the heart of the cosmos begins. But what if the universe is not made of particles but of something much smaller and more mysterious? Imagine a world where everything is made up of tiny vibrating strings. Just as the notes of a melody are born from the vibrations of a single string on a musical instrument, so too could the universe be born from the vibrations of these minuscule strings. This is the basic concept of string theory, a breathtaking perspective on the fundamental nature of our reality. According to this theory, the smallest building blocks of the universe are not particles, as traditional physics has long believed, but are instead these tiny, one-dimensional strings. Now let's delve a bit deeper. Each of these strings vibrates at a specific frequency, and just as the pitch of a musical note changes depending on the frequency of the vibration, the nature of the particle that a string represents changes based on its frequency of vibration. A string vibrating at one frequency might represent an electron, while another string vibrating at a different frequency could represent a quark. In this way, the myriad particles that make up the universe, from the electrons in your body to the photons of light from distant stars, could all be the result of different vibrations of these fundamental strings. This brings a beautiful, almost poetic vision of the universe into focus. Every particle, every force, every piece of matter and energy could be a note in a grand cosmic melody. In this way, the universe could be seen as an incredible symphony of strings. But string theory doesn't stop at redefining what matter is. It goes beyond, stretching our understanding of the universe and its dimensions. In our everyday lives, we interact with three spatial dimensions: length, width, and height. Then there's the dimension of time, creating a four-dimensional reality. But hold on to your hats, because string theory turns this familiar concept on its head. It suggests that our universe may actually be made up of 10, 11, or perhaps even more dimensions. You might wonder, if these extra dimensions exist, why can't we see or interact with them? String theorists propose that these dimensions are incredibly compacted, folded into the fabric of the universe at such tiny scales that they are hidden from our perception. Imagine a piece of paper. From afar it appears two-dimensional, but as we zoom in we see that it has depth, revealing a third dimension. The extra dimensions proposed by string theory could be like that, microscopically woven into the universe we know. It's a concept as mind-bending as it is fascinating. These hidden dimensions could be the key to unifying gravity with quantum physics, a puzzle that has perplexed scientists for decades. They could even hold the answer to the ultimate question: what is the true nature of the universe? So, string theory not only changes our understanding of what the universe is made of, but also how many dimensions it has. String theory, while fascinating, is still a theory. It's a tantalizing concept that offers an elegant solution to the riddles of the universe, but it's not without its challenges and criticisms. One of the main hurdles is that string theory, at its core, is a theoretical framework. We don't have direct experimental evidence to support it. The strings, if they exist, are thought to be so incredibly small that they're beyond the reach of our current technology to detect. And yet the scientific community doesn't stop. Researchers across the globe are tirelessly working to find ways to test this theory, to find that elusive piece of evidence that could turn this theory into a reality. The beauty of string theory is that it keeps us questioning, keeps us searching. It's a beacon in the vast expanse of the unknown. Regardless of whether string theory is ultimately proven or disproven, it continues to push the boundaries of our understanding and inspire us to question the fundamental nature of reality.